Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Khairina Salsabilla. My student ID is 22 11 12 2034. I'm from Department of Food Technology and Agricultural Products. I want to take us through a timeline of what it means to really be measuring atoms. So Democritus is one of the first people to begin to describe our physical world, and then John Dalton is one of the first people to actually perform experiments and begin understanding our physical world. Up next we have J.J. Thomson. So J.J. Thomson's work is really critical because he is the first person to actually show that magnetisms can begin to move and change this atom. He's actually the developer of the mass spectrometer. What it did allow us to do is begin to measure and look at atoms in a different way. He's also the first person to notice that if he changes magnetism, he can actually get a beam of what was pure gas to begin to move. So he's the first person to suggest that maybe there's a thing as stable isotopes or an atom existing in more than one form. Student of his is Ernest Rutherford. So Rutherford worked with J.J. Thomson. What he does is he studies a nuclear decay, and he begins to discover that atoms are actually sort of trying to find a nice neutral charge, and in doing so they'll actually emit radiation, and he discovers alpha and beta radiation, and he discovers that atoms are changing from one form to another. He found that atoms will actually bounce back and off. He describes the atom as having a centralized positive nucleus, and he worked with Sir James Chadwick to discover and describe the neutron, the no-charge atom. I just want to highlight the fact that for over 100 years now we've understood the nucleus, and we've been measuring atoms in a variety of ways for different reasons. We've been investigating and trying to describe our physical world using and measuring atoms for a very long time. So Harold Urey, he takes all this work that's been done before him, and he suggests, well, if there are differences in these isotopes, maybe it's a way that I can concentrate these heavy isotopes. And what he does is he performs several experiments showing that he actually can isolate these different isotopes. And I just want to highlight Harold Urey because he sort of takes all this real high-level physical work and he begins to apply it to our everyday work and to our environment. So why did I bring up all this atomic theory? Well, you know, what we do is we use all this historic innovation and cutting-edge technology to measure these atoms, and in doing so we can answer a variety variety of questions, but what's great about this kind of work is that it's sort of limited to your creativity, or if you're looking for a change, you can potentially measure the atoms and see if that change really happened. And by measuring several different changes, we